going to be presented by Professor Hristina Nikova, and it's entitled Binary Regression Model for Automated Wildfire Early Prediction and Prevention, and the paper is having a co-author, Professor Radoslav Deliyski, and this paper is going to be presented remotely.
So, hello everyone, my name is Hristina Nikova, and I'm a PhD student from the English Language Faculty of Engineering in the Technical University of Sofia. First, I would like to thank you for the opportunity to take part in the conference. So today I will present to you a generation of forest fire prediction model by using a binary logistic regression. So first, let's talk a little bit about the significance of forest and why forest fire prevention is so important. Forests are unique ecosystems and they play an essential role in our life as a whole. They regulate the climate and a lot of other important processes, including carbon cycle. Furthermore, forests are habitat of about 80% of plant and animal species on Earth. The loss of forest may lead to many negative aspects in the field of health, life, and economics. According to last reports, the trends of wildfire occurrences are to increase with 14% by the end of 2030 and 30% by the end of 2050. Only for the last year, USA declared about 3 million hectares loss of burned forest area, which is higher than the last 10-year average records. The Australia, for example, just 2 years ago, declared one of the most devastating wildfire in the history worldwide, which caused 24 million burned forest area. Europe also declared over 2 times more land losses than the last 15-year average for the 2022. So this data is disturbing, which makes the need for managing wildfire occurrences very important. So to meet these needs, an approach for wildfire prediction using the IBM SPSS is made. We build a model through binary logistic regression with the following data as an input. We analyzed 20 of the biggest forest fires for a 10-year period in the region of Whitmore, California. So these are the input data: temperature, current, maximum and minimum value per day, the relative humidity, the solar radiation, the rain precipitation, and 5 more indexes are related to the fuel moisture conditions. On the table below, you can see a sample for one real fire in 209 with the measurements for each of these 10 parameters at the moment of fire ignition, which is registered at 12 o'clock, and respectively 4 hours before the fire. So this is how the input data looks like. And let me tell a couple of more words about the fuel moisture conditions. Fuel moistures is a measurement of the amount of water in a vegetation. There are 2 classifications of fuel moisture depending on the criteria. The first one is by criteria of type and size of the vegetation. We have small and large fuels. The index FM1 characterize the small fuels, which include grass, leaves, small plants, and small roundwoods.
Hristina, sorry for interruption, but the slides are not changing.
Yeah, the slides are not moving.
I'm moving it. Can you see now?
Only the first one is. visible.
Only you're still on the first one.
But I'm changing the slides at the moment. I don't know why you cannot see.
If you have a second display, you're probably moving it to the second display. Right now, it's still stuck in the first slide.
Just a second, let me see.
Yes, right now we move to the second one. Yes, right now we move to fifth one. Now you're on the second. Yes.
I'm sorry. Now can you see?
Yes.
Once again, only the first one.
Only the first one?
Yes.
Yes.
So
now you're the third one now. Now we see. Now we're on the second. Now we see.
So I will make it like this.
Yes.
These are the input data I was talking about just a second before. This is the table with the input data, all of the parameters included for 5 hours from 8 to 12 o'clock. At 12 o'clock, we register forest ignition, and I give you the data 4 hours before the ignition as well. So this is about the fuel moisture conditions, the types, the classification. Let me continue with the large fuels. They are characterized by the other 3 indexes, FM10, FM100, and FM1000. And they are including only round wood with the larger size. The difference between these 3 indexes is that the bigger the number in the indexes, the bigger the size of the round wood is, and respectively, the more time it takes for the water content to evaporate from the vegetation. The second classification is by criteria percentage of water content. If a vegetation consists of more than 30% water, it is considered as light. Respectively, if the content is less than 30%, it is considered as dead. The lower the fuel moisture content is, the more easily the fire would ignite, and the more rapidly the fire would spread. So about the binary logistic regression principles, the output model equation for the binary regression is as follows, where Y is the output and it is a sum of the products between the predictors, which are the so-called input parameters illustrated with X, and their corresponding coefficients B derived from our regression. And then if P is the probability of Y, which equals 1, this means presence of fire, and 1 minus P is the probability of Y equals 0, which means no presence of fire. So the natural logarithm of the odds is equal to the output Y, and finally we receive the probability P, which is equal to the exponential function of Y derived by its value increased by 1. So this is the SPSS output data. As output, we receive this table called variables in the equations, which gives the relation between the input data, that are our predictors for fire occurrence, and the output, where B are the coefficients for the corresponding input parameters. In the column significance, we can actually see which of our input parameters has the most influence to the outcome. The parameter has statistical significance if it is less than 0.05 as a value. So based on this rule, we select only the parameters that are written in the following equation. We select rain, maximum temperature per day, wind, and 4 parameters related to the fuel moisture condition as follow: FM1, FM100, and FM1000, and KBDI. With this equation, we receive the following probability for fire occurrence for the fire in 209. You can see at the moment of fire occurrence, the probability is 78%, and 4 hours before the ignition, the calculated percentage of the probability are close to 0, and only 1 hour before the fire started, it started to increase. So, as a result of our binary logistic regression, we can see on the table a classification of the observed and predicted cases. With letter A, letter A shows cases of state no fire observed and no fire predicted. Letter B shows 5 cases which are positive predicted, but actually no fire was observed. C shows 9 cases of real fire occurrence which are not predicted by the model. And D presents 9 cases of real fire that was correctly predicted as well. The probability, we calculated the probability of true negatives as a percentage, and the percentage is 93. The true positive probability is 50%. The false positive is 35% for our model. The false negatives are 12%, and we can conclude that the overall success rate of the binary logistic regression is 84% in total. So this is my presentation for binary logistic regression for forest fire occurrences. I would like to thank you for your attention.
Thank you, Professor Nikova, for your presentation. For the audiences in the room, do you have any questions about this presentation, about this paper, about this scientific work? There is one question from Professor Filipova-Petrakieva.
Hi,
Yes.
I'm Simona Petrakieva. I have the following question. When you take an...
I'm sorry, I cannot hear.
Professor, you better come here. There is no external microphone.
You use approximation polynomial in a regression model, and you said that the coefficient b in this polynomial are the probabilities of something to be, right? How do you calculate these values of these polynomials? B1, B2, and etc.
B2, they're automatically calculated by the regression.
But how can
This.
you calculate this as exactly value of this coefficient? How get you this value?
I mean,
which
you
type
put
of
as an
observation
input
you need
data.
to calculate this coefficient?
You take as an input data 10 parameters, meteorological, and at this moment we have the information whether there were occurrence of fire or no. We put this both as an input data in the logistic regression, And if you ask for B as coefficient, it comes out as automatically from the regression.
From the model. Thank you.
This.
Thank you.
Okay, Professor Nikolay, I have another question for you. Have you considered, because I have kind of specialist, I have high school forestry education, kind of expert in this field that you are dealing now.
Yes.
Have you considered, because I see lack of parameter, the forest type? Because let's say in the forest, let's say the university forestry, people are told that everybody must mix the tree types in a forest. And depending on the tree types, you have different coefficients. In this case, will result in different coefficients for forest fire. Also, the location and the ground is impacting the decision making. So, have you considered taking data for the forest type? Because right now, I think that your model is incomplete, because let's say the trees in Australia are not like the trees in Bulgaria, not like the trees in
Yes, that's
Germany.
right. Yes, that's right. It really depends on the location. And this is considered by these four indexes, FM1, FM100, FM1000, and FM10. They describe the type of the vegetation and the water content in the life and that moisture.
Okay, thank you. Now,
So you can change.
okay, thank you. Now that is clear, because in presentation this was not stressed that these coefficients represent this. Now
Yes, yes.
Okay.
All of these five indexes that characterize the fuel moisture are connected with the type of vegetation and the water content in the vegetation as well.
Because in the presentation it's only FM1, FM10, we did not know that. Okay, thank you.
Yeah, of course.
Thank you for the interesting presentation. And the next
So
presenter.
if I can add just a few words about the coefficients. These coefficients are calculated by a specific software, which is IBM SS software. And about the second question, this model and these coefficients are derived using the data from specific region in Northern California. Of course, if you use different data from different regions, when we have also different vegetation, the coefficient of the models not most probably, but I believe they'll be different. So this is a model only for specific region, not for Australia or for Bulgaria or for some other places. Thank you.
Okay, thank you. Next presenter is Professor Bojidar Dhzudzhev. I'm giving him the rights as presenter now.
Thank you. Dear colleagues, I will present a paper on the subject of determination of limit of detection in electrochemical biosensors. Biosensors are widely used nowadays, and they are measuring devices that use biochemical mechanisms to detect the measuring substance. They can be divided into three main groups: amperometric, potentiometric, and conductometric. And they have many important parameters, but one of the most important is the limit of detection. There are three methods that can be used to calculate the limit of detection, and these three methods are to calculate it from the instrument resolution, which in our case is not applicable. The second method is to calculate it from low concentration standard deviations. This method is too specific. you need to have several probes, one clean and one with, and the other ones should be with different amounts of subtract, and it's too specific. And as I said, you need to have several probes, and the one method we choose to use is the one to determine it from the calibration curve. This method consists of several steps. The first step is to find the output signal of the electrochemical biosensor. The next step is to determine the calibration curve, and after that we need to calculate several parameters like sensitivity, signal, offset, determinant, and adhesion. We have the limit of the detection. So we made two experiments by using two different electrochemical biosensors. The first one is a plant tissue biosensor. This biosensor is used to measure catechol. First, on the figure 1, we have the transfer function. This function is derived by using different level of subtract on the input input of the device, and recording the output of the device. It is easily seen that from about this point here, we have saturation, which means that no matter how much subtract we put on the input of the device, the output almost doesn't change. Which means that this part of this figure is not giving it any information that we can work with. So after we basically clean this figure, we have the calibration function. The red line is the linearization of this function. After that, by using the formulas we had in the previous slides, we calculate the sensitivity and the limit of detection. We can see here that the calculated limit of detection is above the real value, which means that we use this data and we calculate this limit of detection. We can be sure that this value, we will be able to measure this value, which is a good indicator. We have done a second test with another electrochemical biosensor, which is enzyme-based. Here is given the transfer function. We can see that here is the saturation, and here is the calibration curve. And again, we calculated the sensitivity and the limit of detection, and again the results shows that the calculated value is above the experimental found one. Experimentally found one. So in conclusions, we can say that this method is applicable for this type of sensors. And for further researches, we are currently working to use the method with the standard deviations and we will compare the two of them and see which of these methods give us better results. So, thank you for your attention.
Any questions?
Yes. I have one question for you. Maybe I didn't get it because I was distracted by the beautiful view of the Black Sea that we have here, but you cannot see because you're not here. But you're investigating a specific sensor, right? Or just
Yes.
a range of sensors. So this sensor, I didn't get the purpose of this sensor. What is it measuring?
So the second one, the second one is measuring concentration, the concentration of glucose, and the first one is measuring the first one, the plant fisheries. Yes. I'm sorry, I had thought. It's measuring the catechol.
It's measuring, sorry, what?
Catechol. Vocally fast. Saying it in the right.
All right. Thank you.
Are there any more questions, please? If not, thank you. And this is to Professor Nikova and Professor Bojidar Dhzudzhev. We will receive certificates. You will be contacted by Professor Slavov to receive your certificates. Okay?
Hello everybody, dear colleague. It is a pleasure for me to present you my research work with Professor Galina Cherneva from VTU Todor Kableshkov. We investigate, it is a well-known problem in theoretical electrical engineering. This is the different solutions of Duffing's equation. We make some numerical study about this equation and especially its application in theoretical electrical engineering. The structure of my paper, of our paper, is following. First, we begin with introduction. Next we discuss a model of this equation. We apply this theoretical solution of this model on some numerical examples. And based on these examples, we make a conclusion remarks about solutions of the Duffing's equation. First, it is well known that the Duffing equation is a two-order ordinary differential equation which have a nonlinearity right part, which is a wave form function. We present this function as a cosine function. The application of this equation is when it's describe a different phenomena in physics, ecology, electrical engineering, economic, and etc. One of its important application is for simulation of the behavior of dynamic systems. In this paper, it's applied this Duffing's equation or a simple RLC circuit where the passive elements are connected in serial connection each other. Only the capacitor has a non-linear connection between the voltage on the capacitors and in the charge on it. We have a harmonic input voltage EFT. I'm sorry. In this form. The Duffing's equation has this form, the equation, ordinary equation from second order. The main variable of this equation is the charge of the capacitor. The connection between the voltage on the capacitors and the charge on it is approximate with the polynomial from third order. So when we present this differential equation in a state space, we introduce two variables. First variables is x of t, which is the charge on the capacitor, and second one is y of t, which is which means the velocity of variation of this charge. On this basis, we get the following model in the simple model in the state space. So next, we analyze this model with respect to variation of all of the coefficients in these models. To simplify the presentation and without loss of the generality, we assume that the coefficient A1 and A2 are 1, and we only take in mind the coefficient A3. So the basis points which we have to discuss are these 3 points which coordinate 0, 0, 1, 0 and minus 1, 0. So the respective eigenvalues to these points are has this form, and when consider these eigenvalues, what we see in first one, when we change the value of the coefficient A3, it is obvious that both of eigenvalue are real. But what is important? Important that one of these eigenvalue is negative and one is positive. So the positive one leads to the unstable state, and this is very important for consideration. Second, conjunction values, eigenvalues, lambda plus minus 1 in point plus minus 1, 0 have this form. And when coefficient A3 is positive, the real part of these eigenvalues are negative, so we have asymptotically stable states. When the coefficient A3 is negative, both eigenvalues have positive real parts, and it again leads to a stable state, which is very important for discussing. And when A3 is 0, both of the eigenvalues have only real part. They have no imaginary part because the discriminant is 0, and in this situation we have periodical solution. So what type of graph presentation of the state space we get in these values of coefficients A3? So we make a simulated model of the Duffing's equation, which associate to this state space model. It is very simple, using a Simulink. And which are the results? First, we make we make simulation always when we have sinusoidal voltage source in this form, and the maximum value is 0.5 with 0 initial phase. And first, when coefficient A3 is 0.16, we get for both of the state variables x of t and y of t that they are periodical. And in the phase plane, we get only one trajectory, which has formed a closed loop. So next, when we arise with A3, we become to non-periodical form of the variable x of t, which was the charge on the capacitor, and also the form of the velocity of changing of this variable is periodical. But in this situation, we get a limit cycle which give more than one great closed loops. And in last one, we made simulations with coefficient A3 0.26. So in this situation, it is obvious that both of the variables, the charge and the velocity of changing this charge, are non-periodical variation, and the trajectory shows absolutely chaotic behavior of the system. So, as a conclusion, what was made in this paper? In these papers, we made an analysis of dynamic of passive nonlinear circuits described by Duffing's equation and consists only nonlinear capacitor. Next, we proposed a model in Simulink environment in MATLAB. We test this model when changing one of the parameters of the model, and the behavior of the state space become from periodic to chaotic behavior of the system. And last one, experimental result shows that the changing the system circuits, we can get chaotic outputs despite of the sinusoidal input voltage source. This is for me. Thank you for your attention.
Thank you, Professor, for your presentation. Do we have questions from the room, please? We have one.
One question. Is there any special reason to use cosinus in input voltage instead of sinus? It's not a problem.
No, not a problem.
Okay.
So there are two lines. First one on Russian study and I think German, they use with cosinus.
Okay.
But the other one, USA, use sinus. So this is the same function, which is merged from 90-degree one each other. It doesn't matter.
Is graduation.
Yes.
Yes, the same. It depends on the initial.
If there is any special things.
Yes, okay.
Another questions, please? I have one. Have you considered finding the attractor points? Because I didn't see that in the presentation.
No, we discuss only this typical, no, the other.
Okay.
This is,
You can consider it.
we will consider in future work.
Okay. Thank you.
A not stable solution.
Yes.
Very important.
Yes, of course.
Okay. Next paper is also presented by Professor Petrakieva, and it's entitled Equivalent Transformation of Cube-like Passive Linear One-Port Networks with Equal Impedances in their branches. And one moment, I will hold the presentation for you.
Dear colleague, I will continue with the next paper, titled Equivalent Transformation of Cube-like Passive Linear One-Port Networks with Equal Impedances in their branches. The content of the paper is again introduction, problem statement of the considered problem, next the proposition of equivalent transformations of three types of disk-like cube structure in three types of voltage supply. And next we apply these three types of voltage supply in different contents of the passive elements in the branches of the cube. And the last one, we make a conclusion about our analysis. So, first, The problem considered equivalent transformation of electric circuits is very important because by this transformation we get a simple structure of the circuit, and it is easier for us for interpretation and future analysis of the circuit. And at the same time, when we transform this circuit, the transformation circuit, we have the same values of the currents and the voltages on its nodes. So, it is well known in the literature different transformation of on one side two ports, one ports named two terminals or respective three terminals. So when we have one port or two terminals, we can have serial or parallel connection of the passive elements in each branches, or passive and active sources, voltage or current source in the circuit studied. So in this slide I will in detail describe, not consider, describe the existing connection between this type of connections. So the other type is three terminals, but this type of connection are used very frequently, of course, in three-phase systems. They name star or delta connections, but they will not be discussed in this paper. So, what I have done in the paper, I take a cube with the same impedances in each branch of the cube. In general case, the content of these impedances is the following. Each impedances consists real part resistor R and imaginary part constructed by coil and capacitor with respective inductance and capacitance. So, in this case, the respective two-dimensional model can be presented in this form. So, in this two-dimensional model, it can be supplied by sinusoidal, of course, voltage source in three cases. First case is we have a supply between A and B. So it is supplyment on only one impedance. Next one, I will briefly discuss. Next one, between A and F, between two serial connection impedances, and last one between A and G. This is between three, 1, 2, 3 impedances. So what are the equivalent linear passive circuit in this form? So in the first case we have this equivalent circuit, and if all of the impedances in the branches are equal each other, we get this result about Z equivalent, 7 over 12 Z. Next one, we get the similar connection, 3 over 4, which is equal, of course, 9 over 12 Z. And last one, we get 5 over 6, presented by 12 resistors, impedances which are in the branches of the cube, 10 over 12. So, what we can have a meaning of this impedance? How can be this impedance realized? So this is the results. if we realize that this impedance only with resistor, we get this form only with resistor active part of the equivalent impedance. So if we have resistor and coil which are in serial connection each other, we get this result. Which when we have the resistor and capacitor in serial connection, again we get the respective results. And when we have the serial connection between the passive element, resistor, coil and capacitor, we get these results. So, based on this, what is the connection between these equivalent impedances when we have supply between AB, between one impedance, between two impedance, and between three? I'm sorry, it's my mistake. This can be free. So, but if we take a basic, this one, we see that when we have Z equivalent to, this is this Z equivalent to 1 plus 2 times over 12Z. Next one, 3, this is again Z1 plus 3 times over 12. Well, when 12 is the number of all impedances in branches in the tube. So, as a conclusion, what we can to say, this transformation can be used for studying only active elements in the circuit R. So, in each branches we can have RL elements in serial connection, RC elements in serial connection, and RCL elements in serial connection each other. So, what is important? Of course, it will arise question if in the circuit can be arised a resonance. So in this case, when I discuss no serial or parallel resonance are possible because we have absolutely symmetry between the contents of all the branches. Next one, this transformation help you to simplify the complex structure of this symmetric, of course, passive one ports by presenting only one impedance. And which will be the perspectives for future research of this paper. First, we can do the similar analysis when we use different impedances in individual branches of the tube. Next one, if we make an analysis using active two ports with the same structure in the branches or with different structure in the branches. And last one, the last situation, this one. Thank you for your attention.
We have questions from the room.
I think that it is more new in this work, but it is a something survey and transformation between 3D and 2D presentation.
That also was about to ask that because it's nothing new, it's like a guide in the internet. There is no simulation, at least let's say you can present the simulation.
It's only survey?
Okay, it's in the survey. Okay. Yes. No question.
I think.
Is the comment possible or any questions?
Yes.
Yes.
Okay. I have a few comments. First, its cube model looks like when light strike haven't grounding system. We have grounding system with linear connection to the earth.
Mm-hmm.
But we have without grounding system, we have space cube-like buildings like another structures like rock. They have 3D dimensional, it is the real. But in this case, angular velocity is very high, and current is very high, always some kiloamperes, but only few microseconds, but this model will be implemented in the
G3 case
for the future.
Yes, thank you for
Recommendations.
the advice. Thank you.
Thank you.
Prof. Petrakieva,
Thank
here is
you.
your certificate for
Thank
the
you.
session.
Thank you.
And the thing is the following. Sometimes companies, in this case the Coca-Cola company, needed to introduce a new flavor. Or they are dealing now with alcoholic beverages. Costa Coffee is also they're working with hot beverages. They need to introduce a new product. And first they need to test if this product is going to be well received. And the managers don't want to take the decision only by themselves, because it means that they will take all the responsibility. And for that reason, they ask us, okay, we have this problem, and Coca-Cola company is a centralized company that sends the concentrates. And the local distributor in every country chooses which concentrate to use specifically for the taste of Coca-Cola. There are at least 30 different flavors. And the local branch makes a choice based on the demographics in the place where they are going to sell the product. And the manager wants to make an educated guess what the best taste will be, but let's say if I have one opinion, and my opinion doesn't coincide with the rest of the demographics, this product is going to fail, right? So for that reason, we are taking a focus group. Let's say you're going to be the customers, we're taking a sample of you, to try some of the drink tastes and respond, okay, I would like this or that. But sometimes you don't know what you want, what you like, and for that reason, instead of using only the classical method of questionnaires when drinking, we're going to use physiological data measurements. And you can see questions, answer on the questionnaires for some of the drinks. So there are basically 3 types of drinks. They were simply named drink number 198, drink 680, and drink 782. And this was for Schweppes pomegranate. So there were 3 different flavors, and we have for comparison for base, because Coca-Cola owns Bankia. We had Bankia mineral water and the 3 different tastes. And you can see the opinions are varying to a huge degree. For someone it's good, the other is bad, but it's kind of hard because the drinks are very, very similar taste. They're all flavor of pomegranate. And the conclusion was that the questionnaire provided no clear preference result in this case. And for this reason, because we were using this technique called neuromarketing, when we were analyzing media content, we adapted our procedure to analyze biometrics, such as to use the response that is generated in our brain by using electroencephalography with electroencephalographic apps, by using the response in the pulse with pulse measurement, by using sensors to detect the galvanic ski response, and we also use the electroencephalographic data with a deep learning classifier to detect the emotional states. Let's say if you get a little bit more arousal, or you get a little bit more joyful after drinking from that drink, and so on. So you can see here, even for electroencephalography, and for some of the informational features that the data we're getting. So the postulate is that we place such a cap on the head of the recipient, we measure the EEG signals, we extract the random functions in all of these frequencies, and we perform classification and detection of the walls. And because of this setup, we need to have a procedure how to make the measurement. We made the following procedure. So we first sip the glass from drink 1, then measure the biometrics, then wait for 10 seconds, then sip water to have a neutral taste, then drink 2, then repeat the procedure, then drink 3, and we repeat it 5 times because after five times it's a lot of beverage that's going to be drinked, and people will not be willing to drink anymore, right? And we divided the procedure because when we're denoting the moment when people are touching the plastic cup with the drink as moment 0, no, it's after he finished drinks moment 0. The moment when he drinks is the drinking process, and we can have artifacts of movement. Usually, when you drink, you have evoked potential, so the signals are emitted a little bit time after that, and we are measuring the relevant features from the 2nd to 7th second after the drink is up. So we are measuring the alpha, theta, and ratio of alpha theta frequencies as basic features. And this is a sample set of the measurements that we've done. So let's say I was a test subject, colleague Stiliyan was test subject, so some of the test subjects I don't know their names. Another test subjects, and we needed to create focus groups to aggregate the preference on the data. So for every procedure, so this is moment 0, and this is the 5 seconds we are measuring. And for every drink, so we have one class is water, one class is drink 1, drink 2, and drink 4. That is drink 1, number 198, 618, and 787. As you can see, because the test is quite similar, the results show also what the preference showed, that the results were quite similar. So in the past we've done a similar procedure for much varying drinks, and we had a clear winner. But here, because the taste is almost the same, the difference is 2 of the drinks are with artificial flavor, one is with sugar, so one we were not allowed to use. Because there is now directive that we must use less and less sugar, and they're changing the sugar with aspartame or some other products like that. Yes, and because of that, they want to choose the drink that has more similar taste in response to in our bodies to the one that we were used to in the past. So we have a lot of features, theta, alpha ratio, and then we started to analyzing the 6 emotional features with the deep learning classifier that were for excitement, engagement, interest, relaxation, stress, and focus. Again, we measured, so this is the mean from all these experiments. Let's say for every person we have 5 experiments, and this is the mean for the whole focus group of 11 persons. Okay, and again we can see that the results are very similar, because in this case the drinks were very similar to content. So the results for focus, for interest, for relaxation, for stress, and again we finished with the galvanic skin response, also known as skin conductivity, and the measurements of the heart rate of the pulse. So 2 of the drinks, mostly one of the drink 787, led to a little bit increased pulse and felt a bit more refreshing, so it's a bit like more like the water. And one hint here, this was the drink that was chosen in the end. So electroencephalography didn't show a good separation, but based on heart rate and preferences, it showed that drink 787 is the best choice, and this drink was chosen. And when you go to the store to buy a Schweppes Spawn or Granted, you're drinking drink 787. So we had a group of 23 features: pulse before, pulse after, alpha theta ratios, excitement. Okay, if you want it, you can see the numbers. But we needed to analyze that, and for that reason we created a joint positioning map for all the parameters to get some separation and to try to separate the data best. And based on that, we made evaluation from 0 to 10 on all the products, and it turned out that the best overall score, the winner is drink 782, the third one. And when we make matrix that to present how similar they are the distances, we find that drink 2 and 3 are very similar. Drink 1 is quite dissimilar with the others. And we can see this in this downscaled two-dimensional map. So this is the water, this is drink 2 and drink 3, and this is drink 1. So we can see that drink 2 and 3 are more similar. Drink 1 is very similar and wasn't as preferred. So because drink 3 get the best scores, this was the drink chosen to be the final product from Coca-Cola. And you can buy it in the stores now. Okay. Questions for the presentation?
Okay, let's make some. Suppose we know after first drink alcohol, second and third, it doesn't matter. It's the same on the Coca-Cola. If you put it, when we have a young girl, we put in Coca-Cola rum and another drinks.
It's more delicious.
What's the response of this?
Coca-Cola doesn't so.
Coca-Cola is the same drug like alcohol.
Coca-Cola wants to sell more
like coffee, like Coca-Cola.
But let's say those guys that drink alcohol, they will simply mix the alcohol with a little bit of Coca-Cola. They will not drink more. So the
drink
target.
Alcohol, don't drink water.
Don't drink much water.
Yes.
Okay. or much non-alcoholic. So
who drink beer?
So they're not.
Water.
They're not the target. So we have this pink Schweppes. It's good for cocktails. So it's
after drink alcohol, we have alpha and beta waves and sleeping. After Coca-Cola, it doesn't say. Sorry.
Can I ask what was the 7, 8 to correspond to what type of drink? Kind of is.
We don't know it, so I'll get you on the picture. So they were packed, probably it could be poison, because it's confidential, we didn't know. Okay,
so it's kind of mixed maybe.
I'll show you the pictures. So you can see the bottles. They were packed bottles, they were not Schweppes or anything. They were packed bottles with simply the number. This is drink 182. Okay. So here you can see the bottles, right? And we organize this in 3 different cups. We sip and drink. We drink a little, and we're measuring the reactions when we're drinking this drink. So this is the only way you can try to measure the physiological reaction and to classify it. Okay, this is what we're using. This is what we were given.
All right, and. How you managed to build this cup?
So it's already assembled. It's in the software. In the past we were building cups, but there were always artifacts. They're not good. You don't have. You have to write the software how to process the data and everything. And with this cup, it's called Emotive EG. It's the cheapest solution. It's wireless. So in the past you have to wire everything manually. It's let's say it's very prone to human error because you can get some of the cables a little bit stretched and it sends your everything. It ends your measurement process. But here we simply need to wet up the electrodes a little bit. It's be a Bluetooth transmitter like the presenter that I'm using now. We're sending the information to the PC. We're storing on analyzing in real time with our custom built software that is using the emotive SDK that we're processing that lets us access to the raw data. Because most of the software doesn't gives us access to the raw data in real time. Okay. Yes, Professor Slavov.
Yes, maybe the last question. I was wondering, because for your experiment you used 7 respondents, right?
11.
11. All right. How representative is that, and how did you choose this number 11?
This many.
Is there like
no?
Sorry?
It's very unrepresentative. This much we had.
All right.
This much we've managed to
No, yes, I was wondering, because I'm not familiar with these kind of experiments, how many respondents are required,
because at that time Coca-Cola was changing, so the guys who were working with Coca-Cola get fired.
Oh, right.
So, and there was a budget, but the budget was very low. That they were trying simply to make a variation of the classical thing. So, in the past, we had, let's say, when analyzing media content, we made it this for politicians or for several brands. Let's say, I will not say, but for some banks, for some furniture companies, we analyzed their media clips when people are watching the pre-assembled advertisement. And we're analyzing, we're getting for first second, for second, third second. This is the brain response that we are getting. And we're averaging because, let's say, let's say we have a clip with children. So probably every one of us loves children, but I know people that hate children. So if we start, let's say we wanted to target the population, let's say for shaving, let's say we wanted to sell products to men. If we make it targeted only to women, men will not buy this product, because right now it's Pride Month. Let's say, probably you know, Budweiser lost 30 billion capitalization because they made a can with the colors of the rainbow, and right now in America they discount the beer from 45 cents to 0 cents, and nobody is buying because they say that they're mocking themselves, this is gay beer.
Yes, but Budweiser is Czech.
No, Budweiser, the American, it's Budweiser.
Original is Czech.
Original is Czech, but for the American, right now they lost 30 billion in dollars in 3 months because of one can, and everybody started to joking themselves. Yes.
Can I ask one additional question? Can you remind me all the ingredients of one single test drink? Kind of.
I don't know. It's packed, so it's proprietary to cocoa. I don't know. I don't know what the ingredients are. I just know that one of them was with more sugar or with sugar. The other one was with aspartame.
This is the difference between the test drinks.
I don't know. Just they're simply sealed. They were sealed in boxes. You have the bottles. They're sealed, and that's it. Only get the sticker. This is drink 182. This is drink 7, whatever was the number, and that's it. I told you it could have been poison. We didn't know.
Are the people alive after the?
Yes, I am still alive.
It's dangerous.
I see. A wandering face. Curiosity.
Yes. Okay, any more questions?
What do you think about this experiment? 3 bottles with cups with mineral water, ordinary water, with sugar, with carbon dioxide, and put different colors, dark brown, light brown, like Coca-Cola, and make experiments. What will be the response of these results? Will do the same if you use Schweppes Coca-Cola, because
let's say
people thinks who watch,
let's
not
say
only for.
In the past, we had an experiment where we were having again 2 drinks, but it was forest fruits, lemon, some other variety, and we had a clear winner there by the response of the people. But we're having a variety of exactly the same taste. Probably that when drinking it, it's hard to. They're the same color. They're almost the same taste.
With closed eyes.
No, but their point here is to evaluate the taste, right? So that's why they have to be absolutely similar in the color, in the quantity, so the respondents should just taste it. And of course, when they, you cannot blind them. When they look at the samples, they have to see the same thing. They don't have to.
If you blind, if you see it's Coca-Cola or
no, they don't know that.
They don't know that. They know just number of drink and that's it.
It's just a kind of blackish drink. This is what they know.
Yes.
Exactly. So they want to evaluate only the taste and so
yes.
Yes.
But in this moment, I think for alcohol and drink Coca-Cola. What is the result? I think results.
Right now,
experiment.
Yes.
we'll have future papers. Now we're making measurements when driving, when passengers, when driving a car, with an electric car, diesel car, petrol car. So the difference
is the same.
No, they're different. So
different.
Yes, they're different.
The reductions will be different.
Yes, and they're quite different, and there are difference in the testosterone levels.
Exactly. For an electrical car, you have no noise inside the car. With a gas car, you have the noise, and this always distracts you.
Let's
if you put sound.
Yeah, the sound of the engine. When you're a driver, you know that you don't rely, in fact, on the revolutions of the engine.
But alas, this is sound. So sorry.
You can break.
So the next presenter is Assistant Professor Stiliyan Georgiev.
Hello, everybody, dear colleagues. Nice to meet you. Our paper is related to a simplification of artificial neurons with memristors. The presentation contains the motivation for the work, a short memristor background, a modified memristor model, a memristor-based modified neuron analysis and verification of the results, and the conclusions. The motivation is related to a realization of optimized neural networks, also synthesis and analysis of modified neurons with minimal number of elements, LT-spice realization, and analysis. A very short description of the memristor, which is a passive two-port element having memorizing and switching properties. It is based on titanium dioxide amorphous material. Here is presented the general model. The first one relays the current and the voltage, while the second one is the state differential equation. F is the window function. Here are presented several types of window functions, Stukov-Williams, Jogliker, and Biolek. And here is a very accurate classical model of Leptonian-Laiho. Here is presented a modified model based on Leptonian-Laiho, and the second equation uses activation threshold, which is very useful for applications in memories and neural networks. Here are presented the modified step-like function and also the modified Biolek window. Here is shown the LT-spice equivalent circuit, and there is presented the LT-spice code, which is used for generating the memristor model. Here are presented several current voltage relationships for different frequencies and the same amplitude, and the shrinking of the pinch hysteresis loop of the IV relation confirms the proper operation of the memristor model. And here is presented the link with a unified and open memristor library with LT-spice models. Here is shown the block diagram of artificial neuron having several synaptic weights, the summing device, the activation function, and the output signal. First, we tried to make sorry,
let me continue. So, because I'm a co-author, I will continue from this point onward. So, we are modeling a neuron with membristors. So, we're making electronic implementation of a neural network. And with the membristors, we have multiple inputs up to end voltage, and we have several possibilities to make the implementation. One is by using the so-called passive averager. But the thing is that we don't have very good equation how to set up the weights. Every time when we have to move to the current domain, and we have something like an obtainium, we cannot get the equation for the output voltage. For this reason, we're using also we try to use a non-inverting amplifier, but it provides the same operation like the voltage averager, and it's not useful. For this reason, we settled on using inverting amplifier, because in inverting amplifier we can simply define the different voltages for the current domain, and we can get the final voltage with coefficients defined by the resistor value modeled by the membristors. And we have a piecewise model that for the piecewise model we tried several use cases where we specified certain weight values for the neuron, and we simulated in both on calculated in hand and both in MATLAB, and we get the one-by-one results by what we're having a simulation in the model in LTSpice. The main benefit, so you can see the table, this is a comparison. So the main benefit of this operation by having membristors in the electric circuit is that we can have ladies and gentlemen, the next generation of electric devices will be well powered and very efficient. So we can have, right now probably when you buy goods, let's say from the store, you know that you have an anti-theft system, you have mini circuit boards that they're removing, right? Or that starts the alarm. So in the future you can have structure that instead of using hardware to perform calculation, to perform the artificial intelligence, everybody that was presenting the neural networks that make the decision making, you can have a passive circuit somewhere integrated on a helmet of a soldier. So this circuit, this computer can be powered simply by the movement with MEMS device. So the voltage will be that little. And if we need to change the structure, we simply can feed controlled voltages to reset the values of the membristors. And this makes, instead of having to resolder, make a different structure, we can have predefined standard circuit that does one job, have connections, and simply with a burst of voltage impulses we can have new architecture with new memristor values, in this case new neuron values, and we can have the new updated neural network that is doing better job or different job for the probably, let's say I can have one neural network that is tuned for Stoyanov, I can have one neural network that is tuned for me for my parameters. We can simply do this by setting a controlled voltage, and we set it up. Okay. You have any questions? No. Okay.
First, I will skip some things because they are from the previous presentation. Partially see if it is the motivation and spice realization. Here are the classical models presented for the memristors, and here is the new simplified model. The first equation is simplified by removing the resistors R1 if it is very low, and here is the state equation based on the Leftonen LIFO model, and here is the Jogleker window function. Here is the realization in LT spice, the respective code. Here are presented the time diagrams and respectively the current voltage relationships showing the same behavior as the previous one. Here is presented a simple passive memristor memory matrix and the time diagrams of the state variables and the respective applied voltage. And finally, it could be concluded that the modified model, although it is not so accurate, it has very good switching properties, very good operation in circuits with many a large number of memristors and could be used in memory crossbars. Thank you for your attention.
Are there any questions in the room, please? Questions? If not, then we have our question for Professor Petrakieva.
I have the following questions. As I know, you say that it is energy no sensitive memories using memristor. Is there exist some prototypes or real manufacturing of this type of memories, and how much that it costs? Are they expensive, and is they real? Not only on the papers, on theoretical elements.
Speculation.
And why we study them? Well, it is a very philosophical problem.
Stoyan doesn't know, probably it's not my information to give, but we have one, Professor Mladenov have one board with 61 by 60, 60 by 60 memristors in the Technical University. So it's 256 memristors on a chip. And there are already memristor plants on the Balkans. I will not say in which countries, but they're already manufactured in the Balkans, not in
which is the name of the person? I don't know. You say the name of the person?
No, Professor Mladenov is having a prototype board.
Which faculty is he?
Valeri Mladenov.
Ah! The stressy? Okay. I don't know. Mladenov. Listen, Valeri
economical. It's only engineering.
So we have a chip with developer board, and there is already manufacturing being started. Okay, it's in Serbia.
All over the world. Okay.
In Serbia, there is a plant in Serbia. Okay. Yes, Stoyan, please. Here is your certificate.
I don't know.
Dear colleagues, I will continue with LT Spice applications. In this case, we use this simulator for stability analysis of electronic circuits. This is the outline of our paper. Two main directories. First, the frequency domain simulation using Nyquist criterion, and second is stability investigation based on 2-port S parameters applied to RF circuits. The importance of stability simulation is very high because if we have investigated our stability during the design process, we can ensure correct circuit operation during the application of the circuit or systems. First of all, we consider the application of LT-SPI simulator to construct Nyquist curve. In the case of combination Nyquist curve and family curves using parametric sweep. Next is next approach is to apply Monte Carlo simulation, and both parametric and Monte Carlo simulation using Nyquist criterion. And the method is based on calculation of closed loop gain L. It is important to construct this coefficient without breaking the closed loop in order to ensure high accuracy of the simulation. And here we see that this loop is the gain is expressed by a ratio of 2 voltages from the output of the feedback and the input of the forward block, the equation 1. And depending on the type of feedback, we have 4 variants. The next, first is for series parallel connection, next is for the parallel feedback. In this case, we express the coefficient L using corresponding currents. The principle is the same. How to construct this curve? We use the possibilities of the graphical viewer and introduce the coefficient L in red in the corresponding field at trace expression. Yes, and LT-SPI can build the Nyquist plot automatically. And now we can see the location of the characteristic point with coordinates -1, 0 on this plot, and in this case we see that our circuit is unstable because it passed on the left side up from this point. The specific feature here is the possibility to vary a parameter value. In this case, this is R1 on this plot, and we see 3 different cases. In red, this is a stable circuit. Next to kiloohms corresponds to the circuit at the limit of stability, and finally 3K kiloohms corresponds to oscillator. It is interesting here that this simulation demonstrates an advantage of LT-SPI with comparison to P-SPI, also excellent simulator, but using P-SPI we can no possibility to plot together these variants, because the graphical viewer analyzer can plot Nyquist plot from this series with respect to only one real part, and LT-Spice can place separately each of these curves on the plot, and we can compare the results. This advantage can be demonstrated also using Monte Carlo simulation, because Monte Carlo is a variant of parametric sweep. In this case, we have to define tolerances, and in this form, Monte Carlo and nominal value. Next, define parametric sweep to vary the variance in Monte Carlo simulation, and the result is demonstrated here on this plot. Next plot is a combination of parametric sweep and Monte Carlo. We have vary both parameter and Monte Carlo simulation. This is on this slide. We have explained this specific feature of LT-Spice. Next variant to simulate stability corresponds to RF region. In this case, two port parameters are used, and corresponding stability coefficients are defined using equations 4. In this case, unconditional stability is possible when two equations are fulfilled simultaneously. In equation 4, using the roulette stability criterion, or unconditional stability is given by equation 5. The next criterion is the mu criterion. The advantage here is that we have only one equation 6 for to guarantee unconditional stability. Mu has to be more than 1. Based on these values, especially K coefficient, we can construct another stability coefficients, namely maximum available gain or maximum stable gain. It is important to simulate these expressions. For this purpose, we have to define S parameters in our circuit simulator. We have expressions for S parameters using corresponding voltages from the setup in figure 11. They are the voltages of nodes 1 and 4 for two different setups. first generator VG1 is 1 volt and the load is connected to 0, and vice versa. Second variant, VG2 is 1 and input is to the ground. The specific moment here is that we have to obtain these 4 coefficients using single simulation, because we need 4 coefficients. And for this purpose, a parametric sweep with parameter k is devised. For the magnitude of VG1 and VG2 with 2 values, 0 and 1. And now we have, as a result, 4 all S parameters in the graphical viewer of the simulator. They have the form 11. And in these expressions, V11 is corresponds to the first simulation, and V, for example, 1, 2, V2, 1 corresponds to the second simulation. Now we can use these S parameters in our expressions. In this case, we have an example to visualize the corresponding stability coefficients. And now, once more excellent feature of LT-SPICE is the possibility to construct predefined functions in order to calculate S parameters, magnitudes. In this case, the equations 12, and the functions 13 for coefficient k and delta. Finally, 14 is the expression to calculate the coefficient mu. And Mach and MSG gains 15. The example demonstrates the possibilities of these methods. The results are given in figure 13 for K, delta, and mu. We can see that in the range F1, F2, this is about 1 gigahertz, 0.9 F1 gigahertz and 1.7 gigahertz F2. In this region, our circuit is unstable, and outside this range, we can see both criteria demonstrate the same results. K and delta and mu coefficients are correspond to stable circuit, and the frequencies are the same. And the conclusion summarize the results obtained in this paper. And the most important here is the possibility to overcome the restrictions of another spy simulator, to analyze stability using parametric sweep and multi-cloud simulation. Thank you for your attention.